Hello class, this is going to be our flipped classroom on conversions of grams to atoms and atoms to grams. Now hopefully you've already watched the videos on how to convert from moles to grams, grams to moles, and moles to atoms and atoms to moles. If you haven't watched those two videos yet, please stop now and go back and watch those two videos first, because this video is going to show you how to do a more complicated conversion, going from grams to atoms and then going from atoms to grams. The reason why this is more complex is because this will require two steps as opposed to just one. So first, just a quick review. The term mole is a number. It is 6.022 times 10 to the 23rd. And that's all it means. It's a very big number, but it's just a number. We often refer to it as Avogadro's number. And it refers to the specific number of atoms that you find within a mole. But remember, it is simply a number, nothing more. If we want to figure out how much a mole weighs, well, it's going to depend on a mole of what? Because a mole of one atom weighs different than a mole of a different atom. So for example, let's say I had a question concerning the atom carbon. And I have the information here that I want to know exactly how many atoms there are in 24.022 grams of carbon. So first, I really need to find the moles. To do that, I'm going to go to my reference table just for a second and look up some information. Carbon's atomic mass is 12.011 or 12.011 AMU. That means one atom of carbon weighs approximately 12 atomic mass units. That also means that a mole worth of carbon, or 6.022 times 10 to the 23rd atoms of carbon, would weigh 12.011 grams. That's the number I need. One mole of carbon is that many grams of carbon. So, what I'm going to do is my first step here is I'm going to convert grams to moles. And again, if you watched the previous video, you've seen this done before. I'm going to take the number that I was given, 24.022, and I'm going to multiply by 1 mole over 12.011 grams. Now, why did I do it this way? Why did I put 1 mole on the top and 12.011 grams on the bottom? Well, I wanted to cancel the grams. So if I have grams on the top, I need grams on the bottom. How did I know it was this number of grams? As I just said, I looked in the reference table, and that's the molar mass of carbon. And that is equal to 1 mole. By the way, anytime you have the word mole in a conversion factor, always use the number 1. No exception. So I do my math, and I do that times 1 divided by that, and I get exactly 2 moles of carbon. Now that I have moles, I realize, wait a second, I didn't ask for moles, I asked for atoms. How many atoms are there? But I needed to get to moles first, because now that I have moles of carbon, I can now do the second part. I can say, all right, 2 moles of carbon, that's what we just calculated. How many atoms is that? Well, once again, there are 6.022 times 10 to the 23rd atoms of anything in a mole. Why am I putting this number on top and the mole on the bottom? Same reason why I did this. I want to cancel the word moles. So by multiplying 2 times this number, I get 1.2044 times 10 to the 24th. Now I want to show it to you on a calculator, because I want you to see how to do it using an actual calculator. So here's how I do this math. I'm not going to show you how to do the division here. I'm sure you can do that even without a calculator. With a calculator, I'm going to multiply 2 times Avogadro's number, 6.022. Now here's what I want you to understand. When I do scientific notation times 10 to the 23rd, this is what I hit. I have a button on my calculator that says EXP right at the bottom. You probably have a different button that says EE. It's probably a second function button. But when I touch EXP, an E comes up. When you do your button on your calculator, which is probably an EE button, an E will also come up. E means times 10 to the power of. All I have to do now is hit the number 23. Notice I did not hit times 10. You don't need to do that. As a matter of fact, if you do that, you will get the wrong answer. This button here, which is the same as your EE button, is times 10 to the. So then when I hit equals, voila, 1.2044 times 10 to the 24th. I have a really cool calculator that actually says times 10. Yours will just say e to the 24th. All right, now let's do an opposite calculation. Let's go backwards. Let's figure out how to go from atoms to grams. How many grams are there in 3.011 times 10 to the 23rd atoms of, and this time I'm going to pick boron as my example. So once again, let's look up boron so I know what I'm talking about here. Boron, element B, has an atomic mass of, you probably can't read that, it says 10.81. And again, that's the atomic mass of one atom of boron, but it's also the molar mass of 1 mole of boron atoms. So in other words, 1 mole is equal to 6.022 times 10 to the 23rd. What I'm going to do first is I'm going to do this calculation. Notice that once again, I'm canceling out the bottom word, atoms with atoms. And if I punch this in my calculator, let's confirm that it does work. 3.011, there's my fancy EXP button, times 10 to the 23rd, divided by 6.022 EXP button, 23rd, equals exactly 0.5. 0.5 moles of boron. But wait, I didn't want moles, I wanted grams. No problem, I'll just change moles into grams. 0.5 moles of boron. What does boron weigh again? Oh, that's right, 10.81 grams. I got that from the reference table. Why am I putting the 10.81 on top and the moles on the bottom? Oh, that's right, I want to cancel the moles. So what's 0.5 times 10.81? According to my calculator, 5.405 grams of boron. And that's how you convert from atoms to grams and from grams to atoms.